On August 17, 2026, Massimo Frantarelli revealed that Russia's Project 09851 Khabarovsk nuclear submarine departed Severodvinsk for its first factory sea trials in the White Sea, opening the at-sea test phase for the first submarine designed from the keel up to carry 62M39 Poseidon nuclear-powered underwater weapons. The milestone came exactly 4,404 days after construction began on July 27, 2014, and more than 14 years after Rubin's Central Design Bureau received the design contract from the Russian Ministry of Defense on June 19, 2012. The original contract called for delivery in 2020, putting the program roughly 6 years behind that target when the Khabarovsk finally reached sea trials. The submarine was rolled out of Sevmash Workshop No. 50 on November 1, 2025, and physically lowered into the water around November 30, leaving roughly 8.5 months for completion afloat, mooring trials, reactor and propulsion preparation, electrical integration, navigation system checks, and preparations for operation away from the shipyard. Factory trials must now establish machinery performance, steering response, diving behavior, propulsion reliability, and operation of the integrated onboard systems before state acceptance trials can begin. The Khabarovsk is also materially different from the BS-329 Belgorod, commissioned on July 8, 2022, because the Belgorod was reconstructed from an unfinished Project 949A hull, whereas Project 09851 was dimensioned around Poseidon from inception. The current configuration assigns 6 Tu-P39 launch installations to Khabarovsk, compared with 4 on Belgorod, a 50% increase in embarked Poseidons. After acceptance, the Khabarovsk is intended for the Pacific Fleet in Kamchatka, where Krasheninnikov Bay is being prepared to support Project 09851 and 09852 submarines and their Project 20183 support ship. Confirmed information about the submarine is scarce. For instance, measurements following the November 2025 rollout place the Khabarovsk at roughly 135 meters long and 13.5 meters in beam, with another measurement giving 135 to 140 meters, substantially refining earlier estimates of 113 to 120 meters made before the complete hull could be measured. One reconstruction calculated a main pressure hull diameter near 13 meters and a maximum width of roughly 16 meters across the enlarged forward section, dimensions consistent with accommodating longitudinal Poseidon compartments beside the central pressure structure. Displacement is repeatedly placed near 10,000 tons. For comparison, a 2021 reconstruction put Project 09851 at roughly 120 meters against about 160 meters for Project 955 Bore, with most of the difference resulting from deletion of the Bore's ballistic missile compartment behind the sail. The Bore carries 16 RSM-56 Bulava SLBMs in that section, whereas the Khabarovsk has no equivalent vertical missile block. Project 09851 is also considerably shorter than the 184-meter, roughly 30,000-ton Belgorod because it eliminates the converted submarine's large central special mission section used to support deep diving vehicles. The stern, pump jet area, and rudder arrangement visible after rollout are very close to Project 955A Bore A, while the forward section follows the basic geometry required for Poseidon carriage. In practical terms, the design combines an established large submarine propulsion section with a new weapons bow and deletes the large central payload sections found on both Bore and Belgorod. This is why the Khabarovsk should not be treated as another Russian SSN or SSGN. Its 10,000-ton hull is optimized primarily to move 6 exceptionally large strategic weapons to their launch area. One machinery configuration associated with Project 09851 uses a KTP-6-185 SP pressurized water reactor with roughly 200 megawatts of thermal power and a turbine developing roughly 50,000 horsepower, although an OK650V family reactor has also been associated with the Bore-derived stern. The propulsion train uses one shaft and a pump jet rather than a conventional exposed multi-bladed propeller, while two auxiliary maneuvering thrusters provide low-speed control during docking and confined water operations. Maximum submerged speed is set at 30 to 32 knots, or 56 to 59 kilometers per hour. At 30 knots, the Khabarovsk would cover 1,000 nautical miles in 33.3 hours if it could sustain maximum speed, although an operational transit would normally be slower because acoustic discretion rather than maximum speed is central to submarine survivability. Maximum or normal operating depth is generally placed near 500 meters, draft near 10 meters, crew near 100, and patrol endurance at 90 to 120 days. The endurance figure gives a 30-day spread between the lower and upper estimates and permits multi-month deployments without the submarine's nuclear propulsion being the limiting factor, since food, crew endurance, and consumables become more restrictive than reactor fuel. The Poseidon itself is associated with depths as great as 1,000 meters, meaning the weapon could descend roughly 500 meters below the carrier's estimated operating envelope after launch. The distinction between the two operating envelopes is important. The Khabarovsk does not have to reproduce Poseidon's claimed depth or endurance because its function is to survive the crewed patrol, reach a suitable release area, and launch the vehicles, after which their independent nuclear propulsion assumes the long-distance transit. The forward half of the submarine contains the principal engineering trade-off behind the entire Project 09851 design. The Khabarovsk is configured for 6 2P-39 launchers, with the 6 Poseidons most plausibly divided between two flooded longitudinal hangars positioned along the port and starboard sides of the bow. Large forward doors provide loading and launch pads, while the conventional torpedo compartment occupies the much narrower space between the two Poseidon sections. The arrangement accounts for the unusual width of the bow and has similarities to older Soviet submarines that placed oversized cruise missiles alongside the central pressure hull rather than inside a conventional torpedo room. A double bubble or divided pressure hull geometry has also been associated with the forward section as a means of recovering internal volume between the two large weapons compartments. The dimensional problem is substantial. A Poseidon is most commonly placed near 20 meters long and 1.8 to 2.0 meters in diameter, while the wider range of estimates extends from 16 to 24 meters long and 1.5 to 2.0 meters in diameter. Mass estimates extend from roughly 55 tons through 100 tons to about 110 tons per vehicle. 6 55-ton vehicles would weigh 330 tons, 6 at 100 tons would reach 600 tons, and 6 at 110 tons would total 660 tons. Those figures exclude the mass of the 2P-39 launch installations, support equipment, structural reinforcement, doors and flooding systems. Using the 20-meter length figure, 6 weapons laid longitudinally represent a payload whose individual vehicles are roughly 15 times the length of a standard 533mm torpedo's diameter and whose combined mass can exceed that of several complete small conventional submarines. The Poseidon trades the speed of a ballistic weapon for an underwater route and a much longer autonomous transit. Its nuclear propulsion unit is associated with a range near 10,000 kilometers, or 6,200 miles, and a frequently cited maximum operating depth of 1,000 meters. Speeds most consistently associated with the vehicle are 60 to 70 knots, equivalent to 111 to 130 kilometers per hour, while a 100 knots, or 185 kilometers per hour, figure has also circulated without the same level of consistency. These numbers allow the delivery timeline to be quantified. At 60 knots, 1,000 kilometers requires 9 hours, 5,000 kilometers requires 45 hours, and 10,000 kilometers requires 90 hours.